Hello friends, welcome back. In this video, I am going to talk about slices and their internals in Go language. Let us see what slices are. Slice type in Go is basically an abstraction which is built on top of an array. So slice is nothing but a kind of descriptor which points to the underlying array segment. I'm going to talk about slice internals a bit later in this video. At that point of time, you will come to know what exactly slice is. Arrays are inflexible, but slices are not. So how do you create a slice? You create a slice similar to an array, except that you omit the size while creating it. For example, this particular expression is creating a slice with two elements, hello and world, in it. If it is an array, usually you will be specifying the size, right? If you omit that, then it becomes a slice. Alternatively, if you don't want to initialize the slice values in a single statement, then you can use the built-in make function in order to create a slice. Make function takes the type of the elements that it holds and the length of the slice and the capacity of the slice. While discussing slice internals, you will get a clarity on the exact difference between length and capacity. For now, assume that when you create a slice and specify the length and capacity, the length of the slice cannot grow beyond that capacity. As soon as you use make, internally make allocates an array and returns a slice that refers to that array segment. If you omit the capacity of a slice like this, then it will default to the specified length. This is how you use make in order to create a slice. Here I am creating a slice named another slice which holds the integers and whose length is 4 and whose capacity is 6. That means another slice length cannot grow beyond its capacity. In these two statements, I am actually assigning values to that and I am printing them. Apart from using make, if you already have an existing slice, you can slice that existing slice to create another slice. Sounds interesting, right? Slices can be formed by slicing an existing slice. In this example, another slice is a slice whose length is 4 and whose capacity is 6, out of which I am creating a new slice from index 2 till index 3. Basically, while slicing a slice, you must specify the lower bound index and the upper bound index. It will start from lower bound and it will end till the upper bound, excluding the upper bound. So I am creating a slice from another slice starting from index 2 till index 3 because the upper bound index is omitted. Okay, let me try to execute this particular program and see how exactly the slicing worked there before I move further. Okay, here I am printing a slice which contains hello and world. It printed without any issues. Then I created another slice and I am printing that another slice which holds 2008. As you can see, by default I created with the length 4 and capacity 6, and I am assigning only index 0 and 3, and the rest of the things are assigned to default values, 0 in this case. As you can see, even though the capacity is 6, the slice actually contains only the 4 elements because its length is 4. If you want to grow it, you can grow it. How we can grow, we will see it later. But the slice will have access only to 4 elements. Okay, and as you can see, I used the inbuilt length function and capacity function in order to print the length and its capacity. As you can see, its length is 4 and capacity is 6. Okay, and I am slicing an existing slice to create another slice. In this case, it starts from index 2 till index 3. What does my index 2 contains? 0, 1, 2. It contains 0 and 8. That is why my new slice, which is sliced from an existing slice, contains only 2 elements. Okay. What if you already have an existing array? Can you create a slice out of it? Yes, you can do that. As shown here, this is an array whose length is 4 and contains even numbers. And I am slicing a slice from an existing array. Here, as you can see, I have omitted both lower bound and upper bound. When you omit the lower bound, it will default to 0. If you omit an upper bound, it will default to the length. In this case, the length is 4, so it will become 0, 4. But 4 upper bound index will be omitted, right? So it will contain values only from 0 to 3, 0, 1, 2, 3. So the sliced from an array should contain all of them. This is same thing as I explained earlier. If you omit the lower bound and upper bound, it will default to the values. Let me try to run this and see the output. As you can see, the slice which is sliced from an array contains all the elements in the array because I didn't specify any lower bound or upper bound. Okay. Similar to one-dimensional slices, you can also have two-dimensional slices similar to two-dimensional array. Just make sure that you don't specify the sizes. What happens if you just declare a slice and don't initialize them? Then the slice will be defaulted to nil. That means its length and capacities will be 0 and the slice will not contain any values. As you can see in this particular output, the nil slice length is 0 and capacity is 0 and value is, it does not contain any values. So these are the basics of slices. Basically, slice is an abstraction over an array. You can create a slice either in a single statement using this expression similar to creation of arrays, or you can use the built-in make function. Once you have slice, you can slice those slices to create new slices. If you have an existing array, you can slice that an existing array to create another slice. Now let us try to understand how exactly the slices work internally. As I said earlier, slices are just an abstraction built on top of an array. So how do they look like internally? As you know, in my previous video, I mentioned that array variable actually represents an entire array. That means if you pass an array variable to another function, let us say, in that case, you are actually creating a brand new copy and passing it over. But in case of slice, it is not. Slice is basically as a descriptor to the underlying array segment. This descriptor basically contains three things. It contains a pointer to an array and the length of the array segment that the slice points to and its capacity. Slicing a slice does not actually copy the slice's data. It creates a new slice value that points to the original array. Let us look at example and see how exactly it works. Here I am creating a slice which holds integers whose length is 3 and whose capacity is 6, and I am assigning I am initializing the values with odd values 1, 3 and 5. As soon as I do this, this is how internally things will look like. Basically, make will create an array segment. This array segment, as you can see, contains 6 values because the capacity is 6. But the slice is going to have only 3 elements because I have specified the slice length as only 3. In this case, the slice is going to be a descriptor which holds 3 things: pointer to underlying array. This is underlying array, so the pointer is pointing to the starting index of the slice, and it contains the length. Since it is length 2, it points to, sorry, the length is 3 in this case. I need to change this to 3 because I am specifying it as 3, right? So the slice actually points to till length 3. That means 1, 3, 5. All these 3 things are actually part of this slice, but still the capacity is 6. If you want to grow this slice to have more than length 3, you can do that. We will see how we can do that, but the slice can grow up to its capacity. To summarize, as soon as you create a slice, using a make. The make will internally create an array segment up to the capacity. In this case it is 6, so it is creating a 6 element array, and it is actually pointing to the starting point of the slice and returning that. And the slice actually contains a slice is actually a descriptor which contains these 3 elements. So what happens as soon as I create a slice? If I pass it on to some other function, let us say modify slice. What is modify slice doing? Let us look at it. Basically it is taking a slice and modifying the values to even numbers. As soon as you do that, will the changes made in the modify slice method will be affected here? Yes, because slice is just a pointer. It is a descriptor which contains pointer to the underlying array segment, which is not the case with arrays. Because when you pass array variable to another function, it actually makes a brand new copy. Let me try to execute and see that it is exactly happening. Original slice, as you can see, contains odd numbers 135 whose length is 3 and capacity is 6. Now when I pass the original array to modify method, then it is actually getting modified and the actual contents of the slice is getting changed, which you can see odd numbers are getting changed to even numbers. That is one main difference between arrays and slice. Slice is basically a pointer. Okay, now let me try to go further and try to create a slice out of slice and see how exactly the internal representation changes. From the existing slice, I am creating another slice starting with index 2 and ending with index 4. 4 is excluded. So starting from index 2 to 3. That means how many elements will this new slice contains? Only 2 elements. Index starting from 2 and then 3. This is how it will look like. The sliced slice is again a new descriptor. Remember, this is a new descriptor, but it is not a new array. It still points to the same underlying array segment, but it is a new descriptor which contains a pointer. The pointer now points to the starting index. What is the starting index? The starting index is 2. 0, 1, 2. So the pointer is pointing to the index 2. How many elements will it contain? Since it is index 2 and 3, it will contain only 2 elements, that is 5 and 0. But it will still have the capacity as 4 because the underlying array still has the capacity. Starting from index 2, 3, 4, 5. Total 4 elements are available in the underlying array. So the sliced slice capacity is still 4 even though its length is 2. Let me try to execute that and see how the sliced slice looks like. Sliced slice contains 6 and 0. Why? My original slice contains 2, 4, 6, but the after the third index it will contain zeros, right? So it will contain 0 and it is pointing to starting index 2, right? That is why the sliced slice contains 6, 0. The length is 2 and the capacity is 4. Now let me try to modify the sliced slice and see how exactly it will affect the original slice. The sliced slice 0 index is actually pointing to the second index in the original array. My original slice is also pointing to the starting index, but it still has the capacity till second index, right? So when you change the 0th index, which is actually 2 of the underlying array, it will actually change the original slice too. Let us try to do that. I am changing it to 7 and see how exactly it is changing. After changing the index to 7, the original slice is modified. As you can see, 246 changed to 247. But the sliced slice is anyway is getting changed. The point here is, since the sliced slice is still pointing to the underlying array, once you change it, it is modifying the original slice also, because the original slice is actually pointing to the underlying array segment. Can I do this? Can I try to access the index 2? No, because I said that sliced slice contains only from index 2 to 3, that means the length is only 2. If I try to access second index, that means its length has to be 3. Even though the underlying array has the capacity and it contains 0, the sliced slice doesn't have any access to go beyond its length. If it needs to go beyond its length, which is 2 in this case, then it needs to be grown. That you can do by slicing it again. As you can see, the sliced slice initially contains only 2 elements. Now I am increasing it to contain 4 elements. I am extending it to till the capacity of the sliced slice. As soon as I do this, the sliced slice will get access to the entire remaining array, that is from starting index 2 to till index 5. Okay. These are two important things that you need to remember. Slices cannot go beyond its capacity. If you try to grow beyond its capacity, you can grow up to its capacity, but you cannot grow beyond its capacity. In this case, it will result in an error. Can I access the previous elements? As you can see, the sliced slice, even though it is pointing to 2, the underlying array still has elements before it, right? So if I use -1 and all, can I access that? No. That is where the power of slices are coming in. They are actually putting you restrictions on accessing beyond its capacity as well as below its initial index. Let me try to execute them. Index out of range. This is what I was referring to. You cannot do this. Even though the underlying array segment has the capacity, you cannot do this. This we have seen after modification. As you can see, after growing the slice, initially it has only 7 and 0. After growing the slice, it has 7, 0 and 9, 0. Okay. This is the key. Basically, the slice is a descriptor which contains a pointer to the underlying segment and the length of the segment and its capacity. You cannot grow the length of a slice beyond its capacity. Okay. Now, what else I want to show? How to grow the slice capacity. As I said, once you have a slice with a specific length, you cannot grow beyond that capacity, right? But what if you want to do it? In that case, the only choice that you have is you need to create a brand new array and then copy the slice to that new array. So to increase the slices capacity, one must create a new larger size and then copy the contents of original slice into it. If you want to avoid that, then you can use the built-in copy function to achieve the same. That means you have a slice 1, let us say with size 2, and you want to grow it, then you create a slice with size 4, then copy the values of slice 1 to slice 2 explicitly. If you don't want to do that, and if you want to take care of growing the capacity automatically with a specific algorithm, then you can use the built-in append function. We will see how exactly they work. This particular expression is creating a slice with length 1. That means it will contain only one element, and I am putting that element as 2. Okay. Now I want to grow its original slice capacity beyond 1. In that case, I am creating another slice whose length is 4 and the capacity is 8, and using the built-in copy function to copy all of these. Let me try to execute and see how exactly it works. I am trying to execute grow slice capacity. Original slice, as you can see, contains only one element, which is 2. Now I am creating a copy of it and then copying it with length 4 and capacity 8, and all the original elements in the original slice getting copied to the copied slice. Okay. This is what this copy function is achieving. It is copying the entire original array into the new slice, original slice into the new slice. Now when I change the copy of the original slice, will it change the original slice? No, because the copy of the original is actually a brand new copy. That is pretty straightforward. So if you observe this, whenever you are copying the original slice into a new slice, you have to explicitly make a choice on what is the length of it and what is the maximum capacity of it and all, right. If you want to avoid that and let the go takes care of it, then you can use the built-in append function. What append function does is, whenever it reaches its capacity, it will automatically double the size of the existing slice and then copy the elements. This is the standard algorithm that any other programs also use. For example, if you take arrays and array list in Java, array list automatically grows the existing array and doubles its size and copies it over. Well, we can observe that when we run this program. As you can see, the original slice is contains 2 and 3 with length and 2 and capacity 2. I added one more element. Then since the slice has reached its capacity, it has to grow it. It has grown it by doubling it, right? And then added the value 3. When I appended more elements to it, it reached the capacity 4, so it has to again double it. So the capacity is doubled to 8, but the length contains only 6. This is the standard algorithm that built-in append function uses. If you don't like that algorithm and if you want to do explicit copy by yourself, then you can use the copy built-in function. So this is how you grow the slice capacity. You cannot actually extend the slice capacity with the same memory location. You need to create a brand new slice and copy the original contents into the new slice. Uh, we have seen the slice length versus capacity, right? Basically, once you create an slice, its length cannot grow beyond its capacity. Here I have demonstrated that using a simple example. Initially I created a slice with length 2 and capacity 4, and I used the built-in append function to keep on appending values. As soon as the slice reaches its maximum capacity, it will keep on doubling it. That you can see now. As you can see, as soon as the element 3 capacity 4 is reached in this line, then it doubled it, and once it reached the capacity again, it doubled it, as you can see. That is the difference between length and capacity. Before I end this, let me give you a couple of simple tricks. I don't think this is a very path breaking trick, but if a fun thing with slices. What happens, or how do you exactly remove specific elements in an existing slice? Let us say I have a slice here and I want to remove elements from index 2 to 4. Then you can use this lower bound upper bound trick to do that. Here I am saying that get from starting index 0 till 1 excluding 2, and then get from starting index 5 till end. What is it does? In that case, it removes the elements from index 2 to index 4. What if you want to remove, let us say, just a single element? Then you just use that index for upper bound in both the cases. Here I am slicing it starting from 0 and not including 1, and then including 2 till the end. After slicing all of them, I am appending to a new slice. These are couple of slice tricks which will come in handy. I think that's all I had about slices. The important thing to understand is, in case of array, array variable represents an entire array. In slice, it is not the case. Slice is a descriptor to an array segment. If you slice multiple slices from an existing array, then these slices will still point to the underlying same array segment, but it will maintain the boundary restrictions. You cannot go access beyond slices lower bound and upper bound. Okay, that's it guys. Thank you very much. Let us meet in my next video. See you. Bye.